In this lesson, we will learn the rules to draw ray diagrams for concave lens. So first you draw these two perpendicular lines, and after you draw these lines, you have to mark your points. So at about 4 centimeters, you can mark one point here, then the other one at 8 centimeters. Then on the other side, 4 equidistant points. We mark these points as 2, F1, F1, then this is F2, 2F2. And freehand you draw the concave lens. This is the concave lens. You draw a thin lens. The first ray that we take is parallel to the principal axis. So here is a ray that is parallel to the principal axis. Now after refraction, this is a diverging lens, so it will diverge, but it will diverge, appear to come from the focus. So this will be the direction in which it will diverge. We'll take up another ray. Suppose here now we take a ray parallel to the principal axis, and it will diverge, but when it diverges, it will appear to come from the focus. So here it will diverge in this direction. So a ray parallel to a ray from an object parallel to the principal axis, after refraction from the convex lens, it appears to come from the focus. So let me write here, appears to diverge from the focus. This is rule number 1. Like in this diagram, we see a ray that is parallel to the principal axis, and then it diverges, but when it diverges, it appears to come from the focus. The next rule, a ray of light passing through the principal axis. So first you draw your two perpendicular lines, mark the equidistant points. This is 2F1, F1, F2, 2F2. Then you draw the lens. You need to draw a thin lens. Now this is the case when the ray of light is passing through the principal axis, through the focus. So it comes in like this, through the focus. After refraction, it will go parallel to the principal axis. So this is what is written here. After refraction, it's a concave lens, will emerge parallel to the principal axis. Like in this diagram, we can say even a ray that is heading for the focus, it would have been gone to the focus. After refraction, will go parallel. Like if we were to draw this ray, for example, I take a ray like this that is heading for the principal focus. After refraction, it would go parallel to the principal axis. This is rule number 2. Back again here, this is the concave lens. I think earlier it was written as convex. We are dealing here with concave lenses. This was rule number 1. So you mark your 4 points, draw the perpendiculars. This is the convex lens, which you can draw freehand, concave lens. And now we are going to draw through the optical center. The optical center is marked here, center. So, and the ray that comes through the optical center here will go undeviated, straight down, without any deviation. Like this, a ray passing through the optical center will go undeviated. So here we have the ray passing through the optical center, it goes undeviated. So here will without any deviation. This is rule number 3. However, this is now 2F1, f1, f2, 2, f2. So here we're going to now take the first case. When an object is kept as infinity, you draw your perpendiculars, the 4 points. So this is the lens, concave lens. This is 2 f1, f1, f2, 2 f2. And the object is kept at infinity, means it is kept far away. Objects kept infinity, the rays come parallel. We cannot draw the object here because it is too far away, and the rays from an object kept at infinity always will come parallel to the principal axis. After refraction, they will diverge, but when they diverge, they will all appear to come from the principal focus. This is a diverging lens. Concave lens is diverging. So when you produce this rays backwards, they all appear to come at one point. So here is where the image is formed, f1. So if I were to tell you what is the nature of the image, you can see it is virtual. The rays don't actually meet, so it is virtual. If it is virtual, it will be erect, it will be diminished, and it is formed on the same side as the object. Formed at the same side of object. Here's yet another diagram. Rays that are parallel after refraction, they diverge, parallel, they diverge. This of course to the optical center will go undeviated, and if you produce the rays backward, they will all meet at the focus. So here is where the image is formed, at the focus. On the same side, we have to write here at the focus. Image is formed at the focus. So here let's take up the next case. So here we got to write this is 2 f1, f1, the optical center. Then we have f2, 2 f2. We now draw the lens. This is concave lens, and concave lens I just have one case. Wherever you may keep the object, always the same kind of image is formed. So we take two rays. One ray we take parallel to the principal axis, and the other ray we will take through the optical center, two rays. Now the ray that is parallel to the principal axis after refraction will diverge, but it will appear to come from the focus, and the one that's going to the optical center will go undeviated. And if you see, the rays are now meeting at this point. So this is actually a virtual image. So I'm going to put it in another way. I'm going to put it in a dotted way because it is a virtual image. The object is A, B, and the image here is A dash, B dash. So if I were to ask you what was the nature of the image, we'll say it was virtual, and virtual means erect, diminished. It's very easy to see that the image is diminished. Here is the object, the blue is the object, and the green is the image. And it is formed on the same side as the object. Formed at the same side as the object. So concave lens has just one case, and once again here is the object, two rays, one that goes parallel After refraction diverges, and the other one that goes straight down through the optical center. It will meet at this point, virtual image. Concave lens forms only one kind of image, always virtual, diminished, erect on the same side.